Hello Internet, my name is Quinn and this is Blondihacks. Working on the locomotive this week, continuing with the fire management system, we're going to work on a big new sub-assembly on the locomotive now, the smoke box at the front. So let's go. The smoke box is a compartment that mounts on these studs on the front of the boiler. And it's actually bigger than you might think if you've never looked inside a steam locomotive. It's actually about a quarter of the total length of the locomotive. If we look at an assembled 1/16 A3, shown here with Japanese man for scale, the smoke box is this entire section up here. It looks like all boiler up here, but a big chunk of that is actually the smoke box. And that's for good reason. The smoke box is doing a lot of very important jobs. It is part of the fire management system, as I call it, that we've been working on. Inside the smoke box, the ends of the fire tubes are exposed, and the air comes from the firebox forward and out these smoke tubes and up the stack. And that's really important because, as you may know, the most difficult job in any form of combustion-based power generation is getting oxygen into the system. This is why, for example, we weren't able to forge iron and steel until the mechanical bellows were invented. Similarly, on cars, we have superchargers and turbochargers, which are elaborate mechanical systems for getting more air into the system. We also have nitrous oxide, which is a chemical way to get more oxygen in there. People also use exotic fuels like methanol or nitromethane, which carry their own oxygen into the reaction. Regardless of the method, the problem is the same. Adding fuel to the system is easy. It's always getting more air in that is difficult. So steam locomotives also face this challenge, and the way they solve it is with fluid dynamics. The exhaust from the cylinders doesn't just get released into the air, it actually gets fired out the top of the cylinders into the smoke box, and it's caught by this big cone here, which is hilariously called the petticoat pipe because Victorian engineers are dirty old men hoping for a glimpse of an ankle. That little gap under the petticoat pipe creates draft for the smoke tubes. As the steam is shot up through that area, it's drawing air through the smoke tubes and allowing the fire to draw more air in from the underside of the fire grate back in the firebox. We don't just stop there though, there's also a blower pipe in here, which is a high pressure steam jet directly from the boiler that the engineer can turn on and off, and that creates even more draft for those smoke tubes and draws even more air into that fire to make it burn hotter and more efficiently. The smoke box does a few other minor jobs, but those are the big ones, so let's get started building this thing. We're going to make it out of copper because that's going to be easy to form for the job. It's going to be a great big cylinder, very much like the boiler shell. So this process is going to be very much like making the boiler shell was. I'm going to zip through this a little bit because if you watched the boiler building section at the beginning of this playlist, then you saw all of these steps before. Of course, the first challenge is always cutting long pieces on my bandsaw, which has somewhat of a limited throat depth. These portabands are limited to about 6 inches. You can often work around it by flipping the part around and or cutting away some of the offcut on one side. However, that does destroy the offcut area, and in this case, it's a big chunk of expensive copper, so I don't want to do that. Now, every time I talk about this challenge, someone always says, hey, why don't you modify your bandsaw to twist the blade? That'll give you more throat depth, right? Well, no, friends. No matter what angle the blade is at, the distance to the body of the saw, it doesn't change, and that's what sets your throat limit. These saws are actually very cleverly designed already. There's a half twist in the blade that gives you infinite throat depth on the right-hand side of the blade, as long as you can arrange for the long part of your cut to be there. However, if you need a long part of your cut on both sides of the blade, then there's nothing you can do. It doesn't matter what you do to the blade, it doesn't change that. Sometimes I can finish the cut with a hacksaw blade or a fret saw blade turned at 90 degrees. In this case, neither of those saws have the throat depth either. I also tried finishing the cut with a bare hacksaw blade, and that was a nightmare that didn't work. So I fell back on the same method that I used for the boiler shell itself, which is to score that center area with a Dremel tool. And I can flex that piece and break it off. And since someone always mentions it, no, I can't use my horizontal bandsaw for this either because the throat depth on that big saw, believe it or not, is also just 6 inches, same as the portaband. All right, now we've got a bunch of rough edges to clean up, and for that I'm going to use my sheet metal machining setup. I made this many years ago, and it is a trooper. I really like it. It's just a piece of 2-inch angle iron that I cut down one side of and machined all the faces of it. And this allows me to clamp long, thin pieces very securely all the way down. I used to do this directly on my mill table, but now that I have this fixture plate, it's actually easier to do it in the fixture plate because that allows me to not touch my vise, which is extra bonus. Plus the fixture plate has those alignment pin holes in it, so I can put alignment pins in there. I start with whatever edge of the material looks the straightest, machine one edge, then I can flip that around, line up the now machined edge with those fixture pins and create a parallel edge. Makes this whole process very quick and easy. Once I've got two parallel edges, then I can use those pins once again to register one of those long edges and create the short sides and make sure that they are square to the long sides. And also, of course, by extension, parallel to each other. The other reason I like this setup is that it's very easy to really nail dimensions. And for a lot of model engineering sheet metal parts, such as rolling a shell, the length of it is extremely important. So you need to be able to really nail that dimension to the thousandth and create very parallel sides. Nailed it. Next, a trick I learned from Kozo: while the piece is still flat, mark 3 evenly spaced lines on it, and these lines have become longitudinal reference lines on the finished cylinder that are all exactly 90 degrees apart, including the seam itself. That's very helpful for laying out subsequent features on the shell after you've rolled it. We're going to be doing a lot of work on this shell that's going to require it to be soft and workable, so I will anneal it using the great big torch, because this is quite a hefty chunk of copper. It takes a while to get it warm. I do this in the dark because it's easier to see when the piece is glowing red. If you do it with the lights on, then you're really heating it a lot more than necessary because you're heating it to be a red that's bright enough to overpower your shop lights such that you can see it, which is just a waste of torch fuel. Once that's cooled down, I can take it over to my slip roll. I'm going to start by rolling the shell. I won't be able to do everything with this method, but this will get me close to the cylinder that I need. There's a surprising amount of skill to using a slip roll that I don't have, but I take opportunities to practice because it's the only way I'm going to get better at it. One thing I forgot to do this time was a tip I got from Ron Covell, which is to pre-curl the edges by hammer forming. That really helps when you're trying to make a cylinder with a starting piece that is the exact length of the final circumference. And that's really important here because we're going to be silver soldering this as a butt joint. If you're doing something like welding a cylinder out of steel, then it's often easier to start with a piece that's over length, then roll your cylinder, and then cut the overlapping area to size. But we can't do that here because you can't get a perfect edge by doing that. And by perfect, I mean like machined perfect, which it needs to be for silver soldering the joint. But you can also compensate like I'm doing here by hammer forming the edges to final roundness after the fact. This is a little more work than pre-rolling them. I had to anneal it a second time in order to let me do that, but that also works. That seam gets riveted together with a strap across it. So I'm going to grab a scrap of copper and go over here to the shaper, and I'm going to shape up the rivet strap. There's actually two straps in this case, unlike the boiler shell that had one big one. The smoke box has two little straps on either side of a big hole on the underside of the smoke box. I shaped up one big chunk and then cut it into the two strips that I needed. And as I was staring at this, trying to figure out how am I going to get these two straps riveted in exactly the right place, exactly the right distance apart, and the right distance from the edges, and I realized, you know what? It's actually a lot easier if I just make these two strips as one big strip, rivet and silver solder the whole mess together. Then when I go to make the big hole in the bottom of the smoke box that sits between those two straps, I can simply cut through the strap as well as the shell itself, and I'll end up with two smaller straps in the exact right place. Sometimes this thing on my neck, not just for holding up hats. I'll zip through the rest of this riveting and fixturing process because, again, I showed it in gory detail on the boiler shell. I'm using the same process and, in fact, the same fixturing bar that I used on the boiler shell. I found it in my scrap bin. But briefly, there's alignment lines drawn on the fixture bar. The rivet strap is superglued to the bar, aligned with those lines. Then I align the boiler shell with those lines, clamp everything down, and then I pre-drill and drill for the rivets all the way through the shell and the rivet strap all at once. And because of those alignment marks, everything ends up in the correct positions relative to each other, which is especially tricky here because the rivet strap is actually off-center in the smoke box. You can see I've got all perfectly aligned rivet holes now. That's going to become two straps once we cut them apart. And I need to now remove the rivet strap. I don't want to disturb the setup though, so I do this on the mill, which involves protecting the machine with some scrap metal for heat shields. I want to do this without touching the setup because I want to stay aligned on those rivet holes that I have set up in the DRO, because once this strap is out of the way, I can drill out the rivet positions in the fixture bar a little bit and make them into dollies for the rivet heads. Then back on the bench, I can dry fit everything with rivets, make sure it's all going to fit. Then I take it all apart and I pickle everything, clean everything up, and I reassemble it all with flux between the straps and between inside all the rivet holes and so on, flux everywhere. And then I can cut the rivets to length, peen them down using a ball peen hammer for its intended purpose, peening, in fact, and then I can silver solder this whole thing together. If you're new to this build, I'm sure you had questions about that elaborate process. There's a lot of details there that I've skipped over because they're in the boiler build. Go watch this playlist from the beginning and all will be answered. That went great. It's almost like I'm getting better at this. That seam looks just about perfect. There's one spot on the bottom where if this was a boiler part, I would probably touch that up. But I mean, the strap is sealed all the way around it at the top, so I'm sure it's fine. And this is not a boiler part, so it does not have to be perfectly pressure tight. You kind of want the smoke box to be reasonably airtight to make sure that it generates good draft, but it doesn't have to be perfect. And I'm certainly not going to risk damaging the joint by touching that up because it's not a boiler part. I will also, because it's not a boiler part, file the rivets flush. This is theoretically always possible because the rivets are not peened onto a flat surface, they're peened into a large counter bore that I put on those holes. So the counter bore is what's actually doing the mechanical holding. I did not file them on the boiler though because I didn't want to risk damaging the rivets and creating leaks. Then after all that heating and beaten, we gotta punch the hammer form down there a few times to make it round again because it's gotten a little deformed. The wood former there, by the way, is the same one that was used for the boiler shell. I kept all my wood forms as well because, of course, the smoke box is the same diameter. Similarly to the boiler shell, I found a piece of high-speed steel that fits in that center hole, and I'll use that for tail support. There's also one in the chuck end of it that's keeping the chuck jaws from crushing the tube, and this allows me to face the ends down to length, make everything square as well. And yeah, the tailstock's wobbling a little bit in this setup. This is a block of wood supporting a hammer-formed cylinder. Nothing's going to be particularly concentric, but it's fine. We're just doing a light facing cut. I'm trying to hit a distance between the edge of the shell and the end of the strap, which is different at each end, and an overall length for the smoke box itself. That was a little bit tricky, but not too bad. A little bit more tricky than the boiler shell was, actually. I also want to make sure that the whole thing is square before I proceed, and that's looking really good. So far, so good. First real test fit on the end of the boiler now, and I'm extremely pleased with that. The diameter came out perfect, fits perfectly on the end there. Everything's flush. Very, very nice. Now the logical next step would be to make the mounting tabs that attach this to the boiler. However, let me just show you something real quick. I've got the boiler sitting on the locomotive now on the surface plate. I've zeroed the level on the surface plate. The boiler is sitting level as per the steam dome. But do you notice anything? Unfortunately, probably not because I'm an idiot and the camera is not level. However, to make this easier for you to see, I'll go ahead and put a parallel on those smoke box studs and look at that. 2.5 degrees. They are crooked. It looks like when I was doing final assembly on the tube sheet, the soldering, it got a little bit twisted at some point during that process. I have a feeling I may have actually noticed that after it was done also, but I certainly was not going to cut the boiler apart and fix it. So this is not a big deal though. All it means is when I make the smoke box mounting flanges, I just need to make them a little crooked as well to match. However, what that means is I can't do them next. I need a source of truth for plumb and square on this smoke box. And I don't really have that. I can't use the mounting studs for that. Instead, I'm going to skip ahead a little bit and I'm going to cut a big chunk of brass round bar and I'm going to make the mounting flange for the smokestack. Obviously, the smokestack has to be as vertical as possible, mainly because it'll look really goofy if it isn't. If it's out by a couple of degrees, it'll look like a cartoon locomotive, and I don't want that. So that'll be my source of truth for vertical on the smoke box. This chunk is going to become that little flange, so I'll start over here on the lathe. Seems easy enough at first. I'll face that off, as is tradition. For new viewers, if you were wondering, yes, in fact, that phrase is a reference to the South Park episode about the Royal Canadian Wedding, which is hilarious. don't know why I started saying it on here, but I did. And then I'm going to turn this down to diameter and finally punch a big hole through the center of it to hold the bottom of the smokestack. This is very much like a boiler bushing. It's doing the same job. We need to add some thickness to the top of that thin smokebox shell to allow it to support something larger, such as the smokestack in this case. This pre-drill is a little bit sneaky. I'm going deeper than the final depth of the part on that, and you'll see why momentarily. But it's also a pre-drill for this great big drill. It's going to come in there and get rid of most of that material for me. And then of course I'll finish up with the boring bar. I want a nice accurate dimension on this so that the smokestack will slide in there and be held without rattling or flopping around or being crooked. There's going to be some set screws that actually clamp it in place as well. All right, easy peasy. A simple boiler bushing, right? I can Yahtzee that off and job done. Well, actually no, things are about to get weird. I'm going to Yahtzee this off with extra material on the back, as you can see. And what you can't see in this angle is that that extra long pre-drill that I did is still there. Got that flipped around now, and I'm going to face this square because the parting blade wandered a little bit. Sometimes they do that. I need a square reference surface on the underside of the part, the excess material on the end of the part, in fact, because I'm going to use it for fixturing for the next step. The most astute among my viewers, which is most of you, frankly, you're all very smart, especially you over there, and you over there are really good looking. How you doing? Anyway, you may have noticed that the smoke box is round. And funny thing about round things, the insides of them are concave, which means if you want to solder something flush to that surface, the outside of that thing has to be convex. So we need to create a big convex surface on the top of this very thin part. How are we going to do that? I'm going to cut that curve on the lathe using a fixture block. You could probably file that to a decent approximation, or someone could, but I can't, so I'm going to make it on the lathe. I'm going to start by center drilling a reference hole, then I zero my DRO there, and then I translate over the radius that we require off for that curve minus the current thickness of that part plus the extra material. So by side milling from this position with the DRO telling me the exact correct distance, when I mount the part on this end surface, the final top surface of the part will end up exactly the correct distance from that center, if that makes sense. So I'm going to mark a mounting bolt location here on the end of the part, and I'll drill and tap this to bolt the brass part onto. Then if I mount this contraption in the lathe with the brass part bolted to the end of it, it will be spinning at the correct radius to create the curve on the end of that part that we need. If I can, I'd like to hold this part in the forejaw because it will be easier. And well, I'm holding it using the angled sides of the jaws, which is really not recommended. Those are not gripping surfaces. They're just clearance angles to allow the jaws to get closer together. There's no serrations on them, and using them this way puts some weird lateral forces on the jaws that they're not really designed for, but hey, we've all done it, right? And these are light cuts in brass. It'll be fine. However, this isn't actually going to work because if I bolt the part on the end, the ends of those jaws are sticking out too far and the cutter is going to hit the jaws before it touches the part. That's not going to work. I also tried various other jaw arrangements involving flipping one or more jaws or removing a jaw, and I couldn't come up with a setup that was A, going to work, and B, unlikely to end with a ride to the emergency room. All of this means only one thing: it's faceplate time. This is a pretty easy fixture block to attach to the faceplate. It means a little bit more effort to dial it in, but this is definitely the right thing to do in this case. Now, mounting the whole thing on this faceplate first on the bench and then attaching it to the lathe, I've learned the hard way, is a lot easier than trying to do all this vertically. It's a simple matter now, in theory, of dialing in that center mark. However, dialing things in on the faceplate is a fair bit of work. It involves a lot of tappy-tap-tapping because you don't have any convenient jaws that you can adjust. However, with some persistence, you can do it. Chucks are a relatively recent invention in the history of the lathe. All work used to be done either between centers or on faceplates. I got it to within 1,000th and called that good enough. This is a lot of work, and for this setup, 1,000th is going to be just fine. All right, so in theory now I should be able to bolt my part onto the end, and we are ready to turn. I always give a setup like this a little bit of a hand spin, make sure that none of my clamps are going to hit anything, make sure I'm going to have clearance for the tool and so on. Yeah, looking good. All right, let's make some chips. You know, something was bugging me. Couldn't put my finger... Oh, no. I know what it is. Radius and diameter are not the same thing. I did all this work to create a setup for the diameter of the smoke box, not the radius. Oh, if I had a dime for every time I did that, I'd have at least 50 cents by now. Well, not much harm done. I cut my fixture block in half, and now, conveniently, it's short enough to do the four-jaw method again. I also figured out if I put the block on edge, then it won't hit the jaws. A little help from some parallels to get it square to the machine and dial in that punch mark, which was trickier than you might think. Because I'm holding the part at an illegal angle, there isn't one pair of jaws opposite for each axis of adjustment. So when I need to move the part a little bit one way, I have to adjust two jaws that are at a 45-degree angle to the axis that I need to adjust. Thus, each adjustment involves trying to move two jaws the exact same amount and the tangent of the amount I need them to move. So quite a bit more time-consuming than a regular four-jaw dial-in, but again, not too difficult and a lot easier than a faceplate adjustment. Once again, 1 thou of runout, super fast certified, good enough. Move body out of plane of work, low RPM stupidity check, and nobody died. All right, let's actually make some chips and see what happens. I'm going to blue up that top surface so I can see what the cutter is doing. I'll take a couple of light cuts and inspect, make sure everything's going the way that I think it should go. And this is why you do checks like that, because no, it is not going the way I think. If you can see there, it's cutting more on one corner than the other, and that should not be the case. A little thinking, I realized why this is happening. My mounting bolt is not perfectly in line with the center line of the radius that I'm cutting. And yeah, remember when I made this bolt hole on the fixture block? I just kind of laid it out quick and dirty by hand because I foolishly thought the only thing that matters is the distance between that surface and the center. But in fact, that mounting bolt also has to be on your axis of rotation, or else the curve that you're creating is going to be shifted offset one way or the other, which is exactly what I've got. I contemplated various ways to fix this. I could try to shift the fixture block over a little bit, but that would be tricky to do well, and it was a lot of work to get it dialed in. So instead, I decided to go a little lower tech. I took the piece off, filed out the mounting hole a little bit, which gives me a little bit of lateral adjustment on the mounting, just in the axis of concern. And then I took a series of light cuts and inspected the result, just measuring the amount of material that's been removed from the edge to the Sharpie mark until I got it to where they were the same amount. So once the cut was the same width on both corners, then I know my piece is correctly centered, and away we go. A little low tech, but it worked. I did a high number of light passes here because I don't trust this ill-advised setup a whole lot. I also tend to not stand in the plane of the chuck when doing stupid things like this. The Sharpie is also going to tell me when the cut is finished. My goal is to end up with just a very thin Sharpie line at the crest of the curve, and that'll tell me that the curve is completed, that the surface is fully cut. However, I got to this point here, which looks like I still have a ways to go, and found that I couldn't advance the cross slide any further, even a tenth, without removing all of the blue. And that's actually to be expected because this is a convex surface. When you get very close to the top surface, it's effectively flat at that point. The closer you get to that tangent point, the more the surface becomes an approximation of flatness. And I really couldn't go any further than this, so I decided not to push my luck. I didn't want to end up undersize, or rather under radius, and a test fit confirmed that stopping is the right move because that's really an excellent fit there. Couldn't ask for any more than that. Took a little faffing about, but I think I got that curve cut, and I'm pretty pleased with the result. That's a really beautiful feature, honestly. Really, really looks nice. Let's do another test fit on the bench, and if you get the angle just right, oh, look at that. Boy, I would not kick that out of bed for eating crackers. That is beautiful. And keep in mind, this cylinder isn't perfect either. It's a hammer-formed sheet metal part, but there's no rock in that, and it seats down there perfectly. Boy, that setup was a lot of work, but hard to argue with results. That is just gorgeous. This is why machining never gets old. Now I have to remove all the excess material from the back of that, and I'm going to use the Flexi Chuck for this just because I have it, and it's a great tool for this kind of tricky work holding. I need to enlarge the bore on the end of it a little bit and deepen it as well. The flexi chuck is a flexure holding chuck with a machinable end on it, so you can modify it for each job as you need it. And this will allow me to hold it this way using a very thin holding area so that I can face it all the way down, because the final part's actually very thin. If I didn't have the flexi chuck, there's certainly other ways you could do this. Probably what I would do is machine a custom work holding bore, kind of like I just did on the end of the flexi chuck, and cut slits in it and then put a hose clamp around the fixture and squeeze it tight around the part. I've shown that technique on my channel before. It's kind of like making your own little collet, and that would have worked as well. As I get down to final thickness, you can see all of the fixturing hole go away and the final correct bore is revealed. Looking nice. That part came out really, really beautifully. I'm very proud of that. That was a difficult part to make though, and as a result, it was very time consuming, and I'm afraid that is all the time I have this week. I did not get as far as I would have liked on the smoke box, but we will get back onto this next week. Thank you so much for watching. Thanks to my patrons for making all of this happen, and I will see you next time.